Hi, Year 3. Today we're going to be looking at our first unit in a group of lessons about volume. And before we get started, I just want to clarify that there are two ways of measuring volume. The one that we're talking about for the rest of this week is volume of a fixed area. So it might be something like the volume of a box, or how you could measure the volume of a book. Okay, so to do that, you would measure using centimetres, you would measure the length, the width and the height, and then you would work out what that volume is, and it is in cubic centimetres. Okay, now the other way of measuring volume is by liquids, and we'll be looking at that in a couple of weeks' time, so we won't worry about that now, but that's measured in litres and millilitres. Okay, but that's liquids, whereas at the moment we're talking about measuring the volume of solids. Okay, let's get started. Here we're only going to work with this one today. It's a plane figure with plane means two-dimensional, and it has got 1, 2, 3, 4, 5. Now it looks two-dimensional there, but I want you to think about that as being a set of blocks. Okay, it might be Lego blocks, or it might be the single ones blocks that we use for maths in the classroom. And think about that you were building a tower with those blocks. Okay, so you would start off with the base of the tower being this shape here. Okay, you'd put out your 5 blocks and form that shape there. Okay, what that would look like over here is a table where we write the number of cubes in the base. Okay, and for ours today we're going to have 5 in the base, and our first layer will just be 1. Okay, so over in total number of cubes, with only 1 layer on our base, we have got 5 cubes altogether. Okay, when we go back to here, imagine that we set that on the desk and then we put another block on top of each one of these. So then we would have 2 layers of blocks still forming the same shape. And again, we would need to have 1, 2, 3, 4, 5 more blocks. So how we would represent that is the number of cubes in our base is still 5. We haven't made our design any different, our base design. Now we have got 2 layers. So we have got a total number of cubes. If we had 5 the first time, now we have got 10 because we've got 2 layers with 5 in each layer. Okay, now we're going to go back and put a 3rd layer on top. Okay, still going to have the same number in each layer, same number on the base. We're just putting another one on top so that we've now got 3 layers. So our table will still say 5 in the base. Now we will have 3 layers, which will mean that we have got 15 cubes altogether. And as you know from our times tables, you can see that, look at this, 5 times 1 equals 5, 5 times 2 equals 10, and 5 times 3 equals 15. So with each layer, we're going up by 5. So we've got 5 here. Our next layer will be our 4th layer, and we'll be adding another 5 in to make that 20. Our next layer, if we were to add another one in, would be our 5th layer. And with 5 layers, with 5 on the base layer, we would have 5 times 5, which equals 25. Okay, so this is telling us how many cubes there are altogether, or if our cubes are 1 centimetre by 1 centimetre by 1 centimetre, it would be 5 centimetres cubed, 10 centimetres cubed, 15 centimetres cubed. Okay, let's have a look at that in our step in. Okay, this would be a lot easier to do in the classroom, but you can do it at home if you can find some maybe Lego blocks, or you might have some other blocks. Imagine that there are 1 centimetre cube, because that's what we're dealing with at the moment. In the classroom, our MAB blocks are 1 centimetre cube, so you can think about them like that. But if you've got Lego blocks and you can do this at home, then that would work too. So this is what our base layer looks like. Okay, we've got 1, 2, 3, 4 in our base layer. Okay, and we would put that on the desk in that formation. Okay, with our blocks. Okay, how could we work out how many blocks we would use? All right, so here we've got our number of cubes in the base, just like we did in the last one, our number of layers, and our total number of cubes we have used. Now, rather than try and do my very awkward writing with the mouse, I have set up one over here. Okay, number of cubes in base, which is the same as here, 4 cubes in our base, 1, 2, 3, 4, and our number of layers. In our first layer, we have got 4 blocks. So our total number of cubes is 4. In our second layer, when we put another set of blocks on top of these ones, we would still have the same base layer of 4, and then we would have 2 layers. So our total number of cubes would be 8, 4 on the bottom and 4 on the next layer. When we put our third group on, we've still got 4 at the bottom, still got 4 on the second row. Now we're putting another group of 4 on. So we have got 3 layers. So 3 times 4 equals 12. When we go to our next layer, our fourth layer, we have got 4 groups of 4 layers with 4 in each layer. So that will be 16. If we were to put a 5th layer on, and it's probably getting a bit wobbly by now, we would have 20 altogether. You can see we're going up by 4s, and our multiplication is just our number of cubes in the base times the number of layers. So if we had 6 layers, then we would be up to 24 blocks altogether. Now, this is where we start to talk about it as being volume. What does that mean? That tells us how many blocks we've used. But the volume is how much space something takes up. Okay, so just imagine that you've built this tower of blocks and you've built it layer by layer. And now we want to know how much space that tower is taking up. Just like when we did our area calculation, that area equals length times width. Okay, so in actual fact, our area is our number of base cubes. Okay, 1, 2, 3, 4, and it is 1 dimension, 1 high. Okay, so our area is our length times our width. Okay, except that this isn't a rectangle. Okay, now with our volume calculation, what we can do is we can say that volume equals the length times the width times the height, if that was a rectangle. In this case, it's not a rectangle, but we can still use our area, because back here we have got our area times the height. This one is our area. It's the bottom layer, which takes up how much space on our page. Okay, area is a 2-dimensional measurement and volume is a 3-dimensional measurement. Okay, so our area for the second one, let's have a look over here, 4 times 2 times 4 times 2, area times height, which is our number of layers, so that will be 4 times 2, and didn't set that up correctly. This one will be 4 times 2, and that will equal 8 centimetres cubed. And we write that, just like with area, we wrote it as a little 2 above there, except now that we're doing volume, it's measured in 3 dimensions because it is a 3-dimensional shape. So we need to say that it is measured as cubic centimetres or centimetres cubed. Okay, here's our area again, 4 times 3 equals 12 centimetres cubed. Now again, I'm going to stress it. This is how we measure three-dimensional objects. While we call it volume for both liquids and solids, this one is for solids. And 4 times 4. And our answer, as we know here, will be 16 centimetres cubed, or cubic centimetres. And again, going back, we've got our area of 4 times 5, which is our height, 4 times 5. So we have got 20 centimetres cubed. And our last one with our 6th layer is 4 times 6, which equals 24 centimetres cubed. Okay, so that is how we're calculating our volume of a fixed, like a tower or a set of books or anything that is a solid three-dimensional shape. Our area times our height. Okay. All right, now we're going to just have a look at our book. Okay, we have got, that's what we just did. Here's another one. So here's your area here, your number of cubes in the base and your number of layers. We've done the first two for you. You can see that all you need to do is do that multiplication of area times height. Area of 6 on the base times the height of 2 sets of 6, which is 12. Okay, 3 groups of 6, 4 groups of 6. Okay, you can see your times table is starting to become really useful now. Okay, over here, we have got 5 in our base. 1, 2, 3, 4, 5. We will continue to have 5 in our base, building up one group of layers. How many will be in the first layer? How many in the second layer? How many in the third layer? And you can go on and do the rest. Okay, in this one, you've got 7, so you're not counting this inside area here. Okay, so there's 7 blocks, 1, 2, 3, 4, 5, 6, 7. But be careful because it's not going up by 1s, it's going up by 2s. 1's not going up by 1s, it's starting at 1 and going up by 2s. Okay, and this is where you use 32 cubes to make an object that is the same on each layer. So make sure your base is the same and then draw what it would look like and what the calculation would be. Okay, off you go and do pages 218 and 219.